Okay, so the problem requests us to find the limit as x approaches 0 from the right of this function right here. It does say in the directions to apply L'Hopital's rule, but that doesn't apply directly to this function. See in a second where it does apply. So using theorems on limits, we can rewrite this like this. The limit of a quotient equals the quotient of the limits. Then the limit of a difference equals difference of the limits, etc. Okay, and this is the expression that we have to evaluate using L'Hopital's rule. The rest of this looks like, I'll just put a question mark here for that term. Minus the limit as x approaches 0 from the right of 1 is just 1. Down here we have negative infinity for this term. Minus the limit as x approaches, that's a 0. I should say minus 0 now. And the limit as x approaches 0 from the right of a constant is 1. So that's what we have to evaluate right there, this guy. So that's using the technique of taking the log of both, natural log of both sides. And using properties of logarithms, I can move this exponent down front. Power property of logarithms. It's easier to see this if we rewrite this in exponential form. So y actually equals e to the x ln of x. If I take the limit as x approaches 0 from the right, this is what I end up wanting to evaluate. With that e to the limit of that thing. Will be the limit of y, or x to the x, as x approaches 0. By the way, here I've typed the function on Desmos, and it looks like g of 0.0. It looks like our answer for this should be 0. So let's see if we can make that happen. By the way, if you type g of 0 on Desmos, it will actually give you an answer of 0, even though ln of 0 is undefined. And that's just the way their algorithm works. Okay, so here's what we want to evaluate. We want to evaluate that limit, and then we'll apply e to whatever that is to get the limit of x to the x as x approaches 0. So right now, if I plug in 0 for x, I get 0 times negative infinity. I have to somehow get that to be infinity over infinity, or 0 over 0. I'll just rewrite this as ln of x over 1 over x. And then the limit is negative infinity over infinity, so I can apply L'Hopital's rule. Take the derivative of the numerator, 1 over x, the derivative of the denominator, negative 1 over x squared. So I'm taking the derivative as x approaches 0 from the right of the opposite of x, which is 0. Okay, so, and that means e to the 0 is 1. Okay, and that kind of proves it right here. If we have the function x to the x, as x gets really close to 0 from the right, it looks like x to the x is approaching 1. So back to board 1, this is actually a 1. And that is 0 over negative infinity plus 1, which is the same as 0 over negative infinity. And there's theorems on limits that this thing approaches 0. And that indeed is what this function is approaching as it's closer and closer to 0 from the right. There you go. Hope that helped. If you have any questions, post a comment.